All right, this is 1.7, piecewise functions. Out of this section, you should be able to define and graph piecewise functions, including the greatest integer function. We're not going to really focus on the greatest integer function, but you're definitely going to be able to define and graph piecewise functions. Here's the essential question you have to think about during this section. Homework assignment 15 through 19 in the homework packet. A piecewise function is a function that is represented by a combination of equations, each corresponding to a part of the domain. So you're going to see some graphs and you'll see what a piecewise function looks like. It's separate equations on the same coordinate system. All right, evaluating a piecewise function. First step, when you're giving f of some number, and in this case it's f of negative 3, you want to take a look at this boundary or these boxes. If negative 3 is less than 0, which it is, then you use this equation to evaluate. So you plug in negative 3 into the equation, and what you get is 8. F of negative 3 is equal to 8. So again, first step is the x value that you're using. You take a look at the boundaries. Is 2 greater than or equal to 0? Yes, it is. So you use 4x plus 1 to evaluate f of 2. And when you plug in 2 to 4x plus 1, you get 9. So f of 2 is equal to 9. So the steps again, you're to determine which equation to use by looking at the boundary, and then you plug it into the corresponding equation. All right, so f of 0 is equal to, all right, so 0 is less than 4. So f of 0 is 5. There is no x value, so this is actually a horizontal line at 5. So any number you put in there, if I put in f of negative 1, it would still equal to 5. F of 7. F of 7 is greater than or equal to 4, so we're going to use that equation, 2x plus minus 1. So f of 7 is 13. 14 minus 1 is 13. So again, you determine which equation you use based on the boundaries. X is less than 4, x is greater than or equal to 4, then use that equation accordingly. F of 4 is greater than or equal to 4, so we're going to use 2x minus 1 again, substitute 4 for x, and we get f of 4 is equal to 7. So graphing a piecewise function, we have a formula here. F of x is equal to negative x plus 2, and f of x, 2x minus 5 is when x is greater than or equal to 1, and negative x plus 2 is x is less than 2. So the steps are as follows. You're going to draw an imaginary line at x equal 1. Then you're going to graph each of those equations. And then once you graph each of the equations, you're going to clean up your graph and erase any part of the line that you don't need. And I'll go through the questions with you. But first of all, so this is what the graph looks like once we're complete. The f of x equals negative x plus 2. As you can see, if we drew the dotted line here, our imaginary line, that negative x has a negative slope plus 2 is this line here, and has an open circle because the 1's not included. 2x minus 5, where x is included, is shaded in, and it has a positive slope. Before we get to some examples, let's go ahead and look at the domain and range of these functions first. So domain, what x values can go into this function, or this piecewise function? As you can see, Um, at 6, x is the equation is y equals -4, and it's going all the way to the left. But 6 is not included. But in the other function at 6, 6 is included and goes in the positive direction. So in this case, you can say all real numbers or -infinity to +infinity, and then use parentheses for not included. The range is, you come up from the bottom and you hit the first y, which is -6. You have -6, and then you go up to -4, where those lines are. So that's the range. Domain's x values, the range is the y values. Again, we're going to find the domain and range. The domain in this case, what x values can we input into this function? All the x values we can put are in this function. We can put -infinity to +infinity. All right. Now the range is what the y values are. As you can see, both graphs of the line of the equations are going down -infinity. So the range, we can go down, and keeps on going -infinity down. But as we come up, the y value, the highest y value is 1, and it's not included, so it's a parenthesis. All right, so we're going to graph this piecewise function. What we have to take a look at is where the boundary is. So we look at the 0, we look at this first. So that's going to be at 0, so it's on the y-axis. So then what we're going to do is we're going to go and graph each one of these lines. So we have 4x minus 3. Y is equal to 4x minus 3. We know that the slope is 4, and we know the y-intercept is equal to -3. So let's take a look. Here's -3. Remember that the boundary that we have to go with is 0. So -3 is down here, and the slope is 4. Okay? Now, we can write 4 as 4 over 1 or -4 over -1, depending on the graph. So if we go up 4, 1, 2, 3, 4, and over 1, we have a dot there. But as you can see, our equation is x is less than or equal to 0, so it's going in the wrong direction. But we can still use it and erase it later if we want to, but we can also use -4 over -1, where we go down -4 on the y-axis from the point, and then over -1. And that creates another point that we need. You can see we can create this line. We can go all the way up and create this line. It's a pretty crooked line, but it works. And then we can just erase what we don't need, because we know that our line is x has to be less than or equal to 0, and 0 is included. So let's take a look at 1/4 minus 6. We know the slope. Is 1/4, and the y-intercept is -6. So the y-intercept is -6, so we're down here, and -6 is on our point, so I'm just going to put an open circle there, because that's -6. Now we want to go up 1 and over 4 for the slope. Up +1 right here. So that's our line that we're looking for. So we want to connect these dots as best we can. Use a ruler when you're drawing these lines. So in this case, we have 2 positive slopes, and this is the graph of this function. Let's take a look at this piecewise function. All right, we have our line that we want to work with is -2. You can put a dashed line there if you want. It helps out. It's fine. So this first equation, 2x plus 1, is to the left, and -2 is not included. So I have the slope is 2, and it intercepts the y at 1. So let's just go ahead and take a look at that. Well, you can see that with the 1, the y-intercept is 1. It's to the right of our border, or our boundary, our dotted line. We want to be to the left of that. So what we have to do is find values of 2x plus 1 that'll get us to the right. So I'm going to use what I know. I know this is 2 over 1, or -2 over -1. I need to be to the left, so I'm going to go down 2 and over 1. Here's a dot. I'm going to go down 2 and over 1. Okay, so we're actually on the line right now. This is the point that's on the line, but it's not included. But I'm going to go down 2 again and over 1, down 2 again and over 1, down 2 again. So I have this point now and this line that I just missed because I'm drawing it too fast. Okay, so there's our point. It's on there. Point. All right, so there's our line, and -2 is not included. Let's go ahead and look at the second one. Y is equal to 3. All right, so y equal 3 is a horizontal line at 3. Okay, so we go up to the y-axis, 1, 2, 3, and it's a horizontal line. Now, on -2, it's included, so we draw a big circle and color it in. Our graph says that all the x values have to be greater than -2, so that's the horizontal line at 3. Okay, the greatest integer function, you just have to be able to identify what the standard parent function looks like. Again, the left side is always closed and the right side's open, and it goes and it starts with 0 to 1, 1 to 2, 2 to 3, goes through the middle of the origin. We're going to skip these. Okay, what I want to do is give you one example of how to find the function formula. All right, so we can see that the endpoints are on 0. So we're going to have the endpoints are on 0. The top graph is going to the left of the 0, but it's an open circle, so it's not included, so its x is less than 0. The bottom is to the right of 0, and the point is included. Now, the horizontal line at the top is y, or f of x, is equal to 5. That was simple. So now what we have to do is look at our line. We know the y-intercept of that next line is 0 because it goes through the origin. And to find the slope, we just have to go down 1 and over 1. We find a point on the line. Down 1 over 1, down 1 over 1, down 1 over 1. So we have down 1 over 1 is -1 over 1. Now we just plug it into y equals mx plus b form. So the slope is equal to -1x plus 0. So this equation is just -x. So in this formula then, we have f of x is equal to 5 when x is less than 0, and f of x is equal to -x when x is greater than or equal to 0. All right, I'm going to leave this example for you to try in the class. And then if you have any problems or questions, you can ask your instructor. And then the last part is a practice example for you from the CCSD Common Exam, which is the practice exam. All right, have a great day.